Magnetism, written by Elizabeth Austin, illustrated by John Kastner. Focus question: what effect does magnetism have on modern life? Introduction. Look around your home and try to find a magnet. A magnet is a metal object that sticks to other metals. You might have some magnets among your toys. There are probably magnets on your refrigerator. But do you know that there may be hundreds of magnets in your home? You cannot see most of them. But there is your television, telephone, and stereo. There is electric motors that power your blender and hair dryer. Computers are full of magnets, and all the electricity that runs these things comes from magnetism. Magnetism and magnets. Magnetism is an invisible force. A force is anything that pushes, pulls, or moves an object. Magnetism is a special force that only pulls on some metals, such as iron. A magnet will not push or pull plastic or tin. Magnetism flows in one direction through a magnet, no matter what shape the magnet is. It flows in one end and out the other. The ends of a magnet are called magnetic poles. Every magnet has a north and a south pole. The force flows out the north pole and back in the south pole. You can use two magnets to feel magnetism flowing. The north pole of one magnet will stick to the two north poles together. It feels almost like trying to connect two hoses that are both spraying water. The magnetic force pushes the north poles apart. Because the magnetic forces are flowing against each other, two north poles will always repel each other. So will two south poles. The Earth's iron core is magnetic. The whole planet acts like a giant magnet. If you dangle a magnet by a string, one pole will point north and the other will point south. This is exactly how a compass works. This gave the north and south poles of a magnetic their names. Do you know Earth's north and south magnetic poles are not quite at the true north and south poles? The north magnetic pole is in northern Canada. The south magnetic pole is in the Pacific Ocean south of Australia. Since Earth's core moves around, the magnetic poles move too. They can even flip completely around. If this happened today, your compass needle will point south. Magnetic field. The magnetic force flows out the north pole of the magnet. Then it loops around outside the magnet and flows back in the south pole. The magnetism flows through space in lines of force. The invisible shape formed by the lines of the force around the magnet is called the magnetic field. Any iron or other magnets inside a magnetic magnetic field will be pulled toward the magnet. Stronger magnets have more lines of force and larger magnet fields. To see a magnetic field, place a magnet on a piece of paper. Sprinkle iron flings will gather along the lines of force in the shape of the magnetic field. How are magnets made? The first magnets were made of natural rock called lodestone. People used pieces of lodestone in compasses, but they did not know how they worked. Every material is made of extremely tiny pieces called atoms. This spinning creates a tiny force. In most things like rocks or plastic, the atoms spin every each way. The tiny forces never add up, but when something becomes magnetized, the atoms spin in the same direction. All the tiny forces add up to create a magnetic force. Eventually, people learned how to line up the atoms in some metals to create new magnets. Some things, such as iron, become magnetized more easily than others. A piece of ordinary iron is placed inside a strong magnetic field. The magnetic force makes the iron atoms line up and spin in the same direction. This makes a new magnet. The more atoms that spin in the same direction, the stronger the magnet becomes. Sometimes if you drop a magnet, some of the atoms get knocked out of line and the magnet gets weaker. Make your own magnet. You will need a large iron nail, a strong magnet, and several paper clips. Hold the nail by one end and slide it across the magnet in one direction. Keep sliding it over and over. The magnet's lines of force will start to line up to the atoms in the nail. After 20 to 30 times, touch the nail to the paper clips. Does the nail pick up the clips? How many can it pick up at once? Keep stroking the nail along the magnet to make the nail's magnetic force stronger. See if you can pick all the paper clips at once. Magnetism and electricity. Magnetism and electricity are very closely related. Magnets can make electricity, and electricity creates magnetic fields. This is because both magnetism and electricity affect the way atoms spin. All the electricity you use comes from machines called generators. Generators make electricity by spinning magnets around coils of wire. The magnetism creates an electric current in the wire. The difficult part is getting the magnet spinning. Power plants use running water, wind, or steam from burning fuel to turn the magnets. Electricity can create special magnets called electromagnets. A wire is wrapped around a regular piece of iron. Then an electric current from a battery or outlet flows through the wire. The electric current makes a magnetic field. This magnetics the iron, but the iron only stays magnetized as long as the electricity is on. Using magnetism. The earliest use of magnetism was the compass, a small freely moving magnet needle pointed towards magnetic North Pole. This helped guide travelers and explorers. Modern travelers still use compasses.